guys, welcome to our FRQ Unit 5 study guide. Let's go ahead and get started. Here's our first question. I gave you a graph, and this is the graph of a derivative. Now that's important to understand because if this was a graph of f, it would be different. But with a graph of derivative, that's going to determine how we answer all these questions. So the first thing it says is identify the intervals of increase and decrease for the function f. Explain your reasoning. So notice that it's asking me about the function f, but this is not a graph of f, this is a graph of f prime. All right, so here we go. F increases when its slope is positive, right? In other words, when f prime is positive. And this happens anytime f prime is above the x-axis. So where would that be located? Well, f prime is above the x-axis all the way up to this point, and then all the way up to that point. So I'm going to stop. I'm going to put a stop right there because at that point it's not above the x-axis. It's actually touching the x-axis. So I am going to split this up into two intervals. So it starts at -4, and it stays above the x-axis all the way until I get to 1. And then it bounces off the x-axis and just continues. So then it goes from 1 to 3. There you go. And so that's how you find where f is increasing. Now, let's find out where f is decreasing. And you guys could probably figure that out pretty easily. It's just the opposite of what we did. F decreases when its slope is negative. In other words, when f prime is less than 0. And this happens on those intervals where this graph of f prime is below the x-axis. So here to here, and here to here. So that would be from -5 to -4, as well as from 3 to 4. Okay? So that's how you can find where f is increasing and where f is decreasing by looking at the graph of f prime. Let's go ahead and take a look at number 2 here. Number 2 says, identify the critical values of f. Explain your reasoning. All right, so f has critical values. When f prime equals 0 or is undefined. Okay? This happens at so this is a graph. Remember, this is a graph of f prime, right? So where does this graph of f prime equal 0? Well, anywhere it's touching the x-axis is a place where f prime equals 0. So we have x equals -4, 1, and 3. Now, we also would want to look for places where it's undefined. That would be if there's any holes or gaps or jumps, but there are none. So we can kind of just ignore that piece. We don't have to include that. All right, let's go ahead and move on to number 3 here. Number 3 says, identify the x values of the relative extrema of f of x and explain your reasoning. So, f has a relative max when f prime changes from positive to negative. Okay, now where does that happen at? Well, that means this graph up here, f prime, would be going from above the x-axis to below. And that happens right here. Right now we're above the x-axis, so I'll put f prime is positive there. But then after that, it's below the x-axis, so there f prime is negative. So as we go from here to here, f prime is changing from positive to negative. And so that happens right there at that point at x equals 3. Okay. Contrary-wise, f has a relative min when f prime changes from negative to positive. So where does that happen at? Right now, on that interval, f prime is negative, and on this interval up here, f prime is positive. So at 4, as we move from below to above there, we're going from below the x-axis to above the x-axis, which means that f prime is changing from negative to positive, and so that would be the relative minimum at x equals negative 4. Okay, so that's how you can find your relative extrema. Let's go ahead and take a look at number 4. Identify the intervals for which f is concave up and concave down. So f is concave up when f double prime is positive. And actually, instead of saying is positive, you can, that's fine, but I'm just going to write it like this. So f is concave up when f double prime is positive. Now, the next part that I'm going to write, you don't have to include this in your answer, but I'm going to write it myself just so my answer is more clear. F double prime is positive when f prime is increasing. Because f double prime is the slope of f prime. So if f prime is increasing, that means it has a positive slope, which means f double prime is positive. So basically what I want to be looking for is I want to look for those places where this graph that I have of f prime is increasing, where it has a positive slope. So that would be here, it has a positive slope, and here it has a positive slope. So those are the intervals where f prime is increasing, and therefore f double prime is positive, and therefore f is concave up. So my intervals then would be from -5 to 3, -3, and from 1 to 2. Okay. We could do the same thing talking about concave down. So f is concave down when the second derivative is negative. And once again, you don't have to include this part in parentheses, but I'm going to write it just for your clarity's sake. F double prime is negative when f prime is decreasing. So, in other words, anytime my graph up here of f prime has a negative slope, that means f double prime is negative, which means that f is concave down. So that would be here. We have a negative slope, another negative slope here, and then another negative slope here. Now, I'm not going to... I do want to make this section and this section separate. I'm going to break it off there because that's a cusp and the derivative doesn't exist there. Or I should say, the derivative of my graph doesn't exist there. In other words, f double prime does not exist at that point. So I don't want to say f double prime is negative at that point. It doesn't exist there. It's a cusp. So we have 3 intervals. So f is concave down where f double prime is negative. In other words, where my graph of f prime up here has a negative slope, and this happens on the intervals -3 to 0, my first piece there, followed by 0 to 1, followed by 2 to 4. And there you go. So that's the concavity. Go ahead and take a look at number 5. Identify the points of inflection of F. F has a point of inflection when F double prime changes signs. Now, I'm going to write something in parentheses here again, but you don't have to. I'm just going to write this for clarity's sake. F double prime, which is the slope of this graph up here, the slope of F prime, changes signs when F prime, my graph, changes its slope. So anytime we're going from a positive slope to a negative slope, or from a negative slope to a positive slope, that point at which that switch occurs is a place where I would have a point of inflection for F. So we have a positive slope here and a positive slope here. We have negative slopes here, here, and here. And there are only 2 places where I'm switching from a positive slope to a negative slope. Here and here. So this happens at x equals -3 and x equals 1. All right. On what intervals is f of x increasing and concave up? So now I'm going to ask these questions in a few different ways. So I'm going to make a little color coding key over here for you. F is concave up. Let's write that down first. F is concave up, and I'm going to use the color yellow for that. And for F is concave down, I'm going to use, well, let's go ahead and go with blue. All right. But we also want to know where F is increasing and decreasing as well. Okay. So for F increasing, I'll use green. And for F decreasing, I'll use red. All right. So that's going to be helpful for answering these questions that follow. Now we've already answered all these pieces up here. We've already determined everywhere where F is concave up, concave down, increasing and decreasing. So before I even begin, let's go ahead and remark all of those things. So F, we decided that F is concave up anytime this graph has a positive slope. So that would be here and here. We've decided that F is concave down anytime the graph has a negative slope. So that would be here, here, and here. We've determined that F is increasing anytime it's above the x-axis. Which is that entire region there. And finally, we've determined that F is decreasing anytime it's below the x-axis. This graph is below the x-axis. So there's my color coding. Now let's go ahead and take a look at this. They want to know when F is increasing. Well, we've decided that's green. And they also want to know when F is concave up. Well, we've decided that's yellow. So anywhere on this graph up here where we've got yellow and green, we're in good shape. Okay? So here we go. Let's write our answer out. You have to give an explanation for both of these. So F is increasing when F prime is positive, and F is concave up when F double prime is positive. So this happens when? anywhere on my graph where there is yellow and green simultaneously. And so that would be here and here, those two intervals. And so that's from -4 to -3, and also from 1 to 2. Okay, so, bring some highlighters with you and do the same thing. I think it'll make answering these questions a lot simpler whenever you take your test. All right, let's go ahead and move on to the next one here. Clear this up real quick. Number 7. Now they want to know, when is F concave down and decreasing? So concave down we decided was blue, and increasing we decided was green. So now I'm looking for anywhere there's both blue and green, right? So F is increasing when F prime is positive, and F is concave down when F double prime is negative. This happens on the blue and green regions, which is here and here. So that would be from -3 to 0, and then from 0 to 1. Right. Let's go ahead and move on to the next one. Clear this up first. Number 8. On what intervals is F decreasing and concave down? F is decreasing when F prime is negative, and F is concave down when F double prime, that's concave up. F double prime is concave up when F double prime is positive. This happens where? Well, decreasing is red, concave up is yellow. So we're looking for the regions of this graph where it's red and yellow, and I only see one area like that, and it's right there. And so we're going to say from -5 to 4. All right. Notice that I'm giving my explanation each time. That's the words I'm writing. The words are worth 1 point, and the answer, the interval or the number, whatever, is that one's the one that's worth another point. So each one is worth 2 points. All right, so now we're looking at decreasing and concave down. So F is decreasing when F prime is negative, and F is concave down when F double prime is also negative. This happens on, well, F is decreasing is red, and F is concave down is blue. And so we're looking for blue and red areas, and that would be this guy over here. So we have 3 and 4. There you go. All right, I think that takes care of that one. Let's go ahead and take a look at number 10. This is an extra credit question on your test for Friday. So whether or not you want to do this is up to you. But let's go ahead and see how it works out on our study guide. So it says, let h be this new function here. Identify the critical values of h and determine if there's a relative min or max at those points. So how do we find critical values? Well, you find your derivative and you set it equal to 0. So h prime would be equal to the derivative of this minus the derivative of that, which is 1/4 x, minus the derivative of that, which is 1. Okay? After you find your derivative, you make it equal 0, and that's how you find critical values. You find where the derivative is equal to 0. Okay, so this is where things get a little bit weird for us, though. What I'm going to do is I'm going to add 1/4 x and 1 to the other side. Okay, and that gives me 1/4 x plus 1 equals f prime of x. Okay, so this is my graph that we have already. F prime of x, that's the graph that they have up there. What is this? Well, we can create a new line. We need to create a graph of 1/4 x plus 1. So I don't know if you guys remember how to graph y equals mx plus b, but you start here at your y-intercept and you use your slope to find a new point. So in this case, my y-intercept would be 1, and then I would go up 1 over 4. So rise 1, run 4, and then I would connect my dots. Just like that. Okay? So this is the line 1/4 x plus 1. Now why did I graph that? Well, I want to find out where this graph equals this graph. Well, that happens when they cross. There they're the same, there they're the same, and that's it. So we have two critical values, it would seem here. We have a critical value at x equals -4, and we have a critical value at x equals 0. Okay, so I've taken care of the first part of my question, and now we need to see, are there relative extrema at these points? So, I need some space, so I'm going to erase this. All right. So we found that we had two critical values. We're going to do our number line test. We had a critical value at -4, and we had a critical value at 0. So we're going to do our number line test. And what I'm going to do is I'm just going to pick numbers in these intervals. So h prime of -5, h prime of -1, and h prime of 1. Okay? And we're going to plug them in, and we're going to find out, is h increasing or decreasing on these intervals based on whether we get a positive or negative outcome. So let's do h prime of -5 first. That means I'm just going to be plugging -5 in here. Okay, so what's f prime of -5? Well, this is a graph of f prime up here. So basically it's just asking you what's the y value at -5, and that's down here. So that would be -2. So we have -2 minus 5/4 minus 1. Now, I'm not going to combine all those together. I don't need to. I can see that we have a bunch of negatives being put together. So the answer is going to be negative. So I don't really care what the number is. I just care about if it's positive or negative. So we've got a negative slope here, which means that the next one's probably going to be positive, but I'll check just to be sure. All right. Next one, h prime of -1. h prime of -1. All right, f prime of -1 is up here now. I don't really know what that is, but we can estimate it. It doesn't look like 1.5, so I'm going to guess maybe like 1.25. Multiplying this is going to be a positive 1.25. And I can already tell this is going to be bigger than 1, so if we subtract it, we're going to end up with a positive. So I end up with a positive value there. And then finally, we're going to do h of 1. So you would just plug that in as well. So h prime of 1, f prime of 1. This one should come out negative because it usually just kind of goes back and forth. We have negative, positive. It should be negative, but we'll see. It's not always like that. Sometimes it does throw us for a loop. Let's do f prime 1. So this is 0, and this is negative 1/4 minus 1, which, yes, once again, that's negative. So there you guys go. And therefore, we can see that at negative 4, we have a relative minimum, and at 0, we have a relative maximum. So our final answer, after showing all that work, is we would say h has critical values at x equals negative 4 and 0, since h prime equals 0 at these points. And h has a relative max at x equals 0, since h prime changes from positive to negative at that point. I'm running out of space there, sorry for the squishy writing. And we would say that h has a relative min at x equals negative 4, since h prime changes from negative to positive at that point. Okay, so this is our explanation, but you do have to show your work, you know, all the other stuff that you did, like finding the derivative and whatnot. Like I said, that's an extra credit question. It's up to you whether you want to do it or not. Let's go ahead and move on to number 11. So we're switching gears here. We're going to a table instead of a graph. It says identify the critical values of g and explain your reasoning. Notice I've changed my function from f to g. That caught a few of you guys on the quiz. You've got to name them correctly. You can't change the name to f. And since we use f all the time, it's really tempting to write f. In fact, you might see me do it right now in this quiz at some point. But we got to be careful to not change the letter. All right, so it says identify the critical values of g and explain your reasoning. So g has critical values when g prime equals 0 or is undefined. This happens at, let's see, here's g prime. And I'm going to look through this row to see if anywhere equals 0 or undefined. There's 0. And there's 0. There's no undefined though, so we have two places where my derivative equals 0. And these things happen at x equals negative 4 and x equals 0. Okay, that's critical values. Let's take a look at number 12. Identify the values of x of the relative extrema of g. Explain your reasoning. So g has a relative max when g prime changes from positive to negative. This happens at, let's find out. So where does g prime change from positive to negative? This is negative to positive. That's no good. I want positive to negative. No. So that doesn't seem to happen. I don't seem to have anywhere up here where the derivative changes from positive to negative. That can happen. And so in that case, we're going to erase this part of our sentence, and we're going to say this does not occur. There you go. Now let's go ahead and do the minimum. G has a relative minimum when G prime changes from negative to positive. This happens at, we already found one right here, right? Here it goes from negative to positive at this middle point here, switches at x equals -4. And I don't see any other ones up there where we're switching from negative to positive on the G prime row. All right, let's go ahead and take a look at number 13. And just so you guys know, there is another way to explain your answers here. Instead of saying G prime goes from negative to positive, you could say G is defined, G prime equals 0 and G double prime is positive. That is another way of identifying a minimum. Contrarily, a way of identifying a maximum is if you have a defined point where the derivative equals 0 and the second derivative is negative. But we just don't have any of those things going on here. So let's move on to number 13. Identify the points of inflection of G. G has a point of inflection when G double prime changes signs. This happens at, here we're changing from positive to negative, and there is a point at that location. And we're also changing from negative to positive here at this point. So we have 2 points of inflection. So here's one point. My x value is -2, my y value is -2. And my x value is 0, my y value is 2/3. Now, you'll notice that on most of these questions, I've been putting like at x equals. I could have said the same thing here. I could have said at x equals -2 and x equals 0. It's fine. Or you can just write them as points. That's fine as well. It doesn't really matter, but there you guys have it. Number 14, is there a value of c for which g of c equals -3 on the interval from -4 to -2? Justify your conclusion. So before I do number 14, I want you guys to compare and contrast that with number 15. Very similarly worded question, but here, this one on number 15 says derivative, whereas on number 14, it's not a derivative. When it's not a derivative, this is an IBT problem. And here's how the IBT works, okay? Basically, we're going from, you don't need to draw this, but I'm going to go ahead and draw it. We're going from x equals -4 to x equals -2. Once again, you do not need to draw this. You're not going to put this on your test. You can, it won't hurt, but it will take time from you. But I do want to take time to explain it now, so it makes sense when you get to your test. So I'm going to plot this point first, -4, -6. And then we have this point here, -2, -2. All right? So I don't know how to connect these dots. Do they connect like this? Or do they connect like this? Or do they connect like this? Well, it doesn't really matter how they connect. The point is that if I'm going from there to there, the question is there somewhere where g has to equal -3? Well, here's where -3 is at, so that would be right about here. So yes, in order for me to get from this point to this point, I would eventually have to cross -3, no matter how I drew my line. If I drew it like that, I'd be crossing -3 over here instead. But the point is, eventually, if you're going from a y value of -6 to a y value of -4 to a y value of -2, you're going to have to cross a y value of -3. That's the IBT. But how do you write it? Here's how you write it. You would say, since g is continuous, on the interval. This is important because if it's not continuous, then this theorem may not apply. If you have a hole or a gap, it may never equal negative 3. It says G is continuous on negative 4 to negative 2 and goes from the y value, negative 6 to negative 2, there must be some value c such that g of c equals negative 3. That's how you write your answer. Now, you don't necessarily have to say it this way, but there are some things that you need to say. You need to say that it's continuous. You need to state the interval of the x values. You need to state the interval of the y values. And then you need to state your conclusion that, yes, there must be some value of c. Okay, so those are the 3 things. And to me, this is the easiest way to word it, but it's up to you. All right, now let's go ahead and take a look at number 15, which looks a lot like number 14, but it's different because there's a derivative there. Okay. Once again, I'm going to draw a picture, but you don't really need to draw a picture of this. And I would say don't draw a picture. I just want to explain it to you before I begin the problem. So we're going from negative 2 to 0. So that's here to here. So I've got a graph that's going from negative 2 to 0 and 2/3, which is right about here. Now, I don't know how these dots connect, but I'll just draw a little line like that. Well, G prime of C, that stands for a rate of change. They're asking, is the slope at some point negative 4/3? Is there a tangent line that has a slope of 4/3 somewhere? I'm going to guess it to be right about here for now. So the answer is yes. And the reason for that is because the secant line that connects the endpoints is going to have a slope of 4/3. And somewhere along that curve, those are going to have to be parallel. That's what we're looking for. But that is the idea we're going for there. It's a different idea. It's looking for where slopes are equal rather than where y values are equal. So anyway, let's go ahead and begin here. So we're going to say, since G is continuous on negative 2, 0. Now you might be wondering, Mr. Bailey, how do you know it's continuous? I don't have this part of the directions on there, but if you guys look at your study guide, there's some instructions under the table that tell us that this function is differentiable, which means that it's continuous also. So since G is continuous on that interval, and G is also differentiable on this interval, it's the same thing but with parentheses instead, there must be some value c such that the following occurs. G prime of c is going to be equal to G of 0 minus G of negative 2 over 0 minus a negative 2. Now G of 0, that's the y value that goes with the 0, which is 2/3. G of negative 2, that's the y value that goes with negative 2, which is negative 2. On the bottom here, we're just left with a positive 2. And I have here 2 over 3 plus 2 over 2. How you want to solve this is fine. On your test, there'll be weird ones like this too with fractions, and feel free just to use your calculator and do decimals. So you're just going to do 2/3 plus 2 divided by 2. You could also simplify it by hand if you know how to. But like I said, there's going to be some on your test where I'd say just go ahead and use your calculator. It's fine. So I'll type it into my calculator really quick. Just give me a moment. and I get about 1.3 bar on top. Okay, and that is what 4/3 is equal to. Okay, it has to come out to match this in the end. If it doesn't, something's wrong. So there it is. So since g is continuous and differentiable, there has to be some c value such that the tangent line is equal to the average rate of change, the slope of the secant line, on that interval. All right? All right, last question here on our FRQ study guide, number 16. Let this function here have a critical value at x equals -1, find k. So since we're concerning ourselves with critical values, that means we're going to find the derivative and set it equal to 0. So the derivative of j, power rule, would be 2kx minus 6. We're going to do two things. We're going to set it equal to 0, because that's how you find critical values. And we already know what our critical value is. They tell us it's -1, so I'm going to plug that in for x, because that's the critical value. From there, we'll be able to solve for k. So I end up with -3. Now, for part B, they want to know, is that critical value at -1, is that a relative min, max, or neither? Well, we're going to do our number line test. We're going to put -1 here. And what we're going to do is we're going to plug a number in to our derivative that's to the left of -1, and a number to our derivative that is to the right of -1. Now, we wouldn't be able to do this if we hadn't found k earlier, because here's my derivative, but now I know what k is, so I'm going to plug that in here. I'm going to plug in -3, and that gives me j prime of x is equal to -6x minus 6. So we could just plug in our numbers here to our derivative and see what we get. So -6 times -2 minus 6 is 12 minus 6, which is 6. So that's a positive slope. And then plugging in 0, we get -6, so that's a negative slope, which means we have a relative max. So we would say, since j prime changes from positive to negative at x equals -1, there is a relative max at that point. And there you have it. Okay. So that'll end our FRQ study guide. Hopefully that was helpful, and we'll see you guys in class.